Okay, in this video, we're still looking at theorems that show sufficient conditions for two quadrilaterals to be congruent to each other. So we've already seen side, angle, side, angle, side in the previous video, but other congruence theorems are, and these ones work, angle, side, angle, side, angle, side, angle, side, angle, angle, and side, angle, side, side, side. And we're going to prove one of them. We're going to prove the first one, AS, AS, A. At least sketch through the proof. Okay, so prove AS, ASA for quadrilaterals. Here's the figure. I've got a quadrilateral ABCD and a quadrilateral XYZW. What we'll do is we're going to suppose we have an angle, side, angle, side, angle pairs that are congruent. So angle A is given to be congruent to angle X. Could have started anywhere, but I'm just starting with the first one, A and X. And we're going to go around clockwise. AB, that side, is congruent to XY. Angle B, the next one, we'll put two notches around that one, is congruent to angle Y. And then the line segment BC, 1, 2, 1, 2. And then finally the angle C, 1, 2, 3, 1, 2, 3. We are given that those are congruent. So we have angle, side, angle, side, angle. Well, all it remains to do is show, remember when we defined AS, 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 1, 2, 3, 4. I may have put the S at the beginning before, but it doesn't matter. I've got all 8 of them going around one direction or the other. So if we have AS, ASA, all I have left is to show that the remaining 2 sides and the remaining one angle are congruent. So let's see how we can prove this. Okay, so it remains only to show these 3. So once again, I have an angle, a side, an angle, a side, and an angle. And then I need to go with side, angle, side. This is all I need to show. And let's just make sure I got the letters right. AD, yeah, the bottom side, XW, angle D and angle W, and then this side CD congruent to this side ZW. All right, this shouldn't be too hard. Let's begin by drawing a diagonal AC, like that, and the corresponding diagonal XZ. Notice we have triangles now. We're going to actually use triangles like we did in the previous section. Let's label the new angles formed. Instead of angle A here, it's now broken into 2. I'm going to call this one angle 1, call that angle 2, call this angle 3, call that angle 4. And then in a corresponding way, I'm going to come down here and do 5, 6, 7, and 8. 5, 6, 7, and 8. So now, for example, this angle Z, the measure of that angle is equal to the measure of angle 7 plus the measure of angle 8. All right, so now what can we do? Let's see. Let's take a look at this triangle, the upper one, upper left, I guess I'll call it, ABC, and XYZ. Is there anything we can say about those 2 triangles? Well, let's see. I don't know that angle 2 is equal to angle 6, but I do know that this side is the same as that side. And then this angle is the same as that angle. And this side is the same as that. So in these two triangles, I have side, angle, side, side, angle, side. So I can say that triangle ABC is congruent to triangle XYZ. Oops, X, Y, Z. Great. Now I'll go ahead and put by side, angle, side. All right, well, what does that tell us? That tells us a couple of things. That tells us that angle, let's see, angle 2 is congruent to angle 6. That's easy. It's just corresponding parts. If this triangle is congruent to this triangle, all their corresponding pairs are congruent. So I'm going to say that angle 2 is congruent to angle 6. And I'm also going to say that angle 3 is congruent to angle 7. Both of those are true because corresponding parts of congruent figures are congruent. Well, what does that tell us? We know that angle A and angle X are congruent. We were given that right here, angle A and angle X. Well, let's see, how can we, without, I'm going to try to do it without writing every little step down. But I guess I can say that angle A congruent to angle X and angle 2 congruent to angle 6 implies what? Well, if angle 2 and 6 are the same, and the big angle A is congruent to angle 6, that forces angle 1 and angle 5 also to be congruent to each other, because a measure of angle 5 plus a measure of angle 6 is equal to the measure of angle X, which is the measure of angle A, and the measure of angle 2 is measure of angle 6, so that means the measure of angle 1 must be the measure of angle 5. So I'm just going to write it that way. Those two imply the measure of angle 1 is congruent to the measure of angle 5. That was just basically by simple addition of angles. So now we have this angle. I'll put 1, 2, 3, 4 maybe. Angle 1, 1, 2, 3, 4. So that angle is congruent to that angle. Well, by the exact same logic, we have that the measure of angle, I'm going to put similarly, we have that the measure of angle 3 is equal to the measure of angle 7. It would be that's by corresponding parts. We have that right here. So that and the fact that, now let me write it all out. The angle C congruent to angle Z and angle 3 congruent to angle 7 implies that 4 and 8 angles are also congruent. So I guess I didn't need the measure here. You just say an angle is congruent to another angle. So this would be the angle 4 and angle 8 are congruent. Okay, so that means that I'm just going to make it look like this and this. So now what do we have? Since this angle, triangle and this triangle are congruent, we know that by corresponding parts, we know that AC is congruent to XZ. And so I can say now by angle side angle, angle, side, angle, that triangle ACD is congruent to triangle XZW. By angle, side, angle. Okay, so now we get that. Since this and this triangle are congruent, we know that 1, 2, 3, 4, 1, 2, 3, 4. We know that CD is equal to ZW. We know that, how should I do this one? 1, 2, 3, 4, 5. We know that angle D is congruent to angle W. And we know that this side, which I'll use 5 notches, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. That's the final side we needed. AD is equal to ZW. I wrote it slightly differently here. AD is congruent to XW. Congruent because I made them look like line segments, which I can go ahead and do that. Line segments. So we have these three proven here. And this is by corresponding parts of congruent figures are congruent. And that is the end of that proof.